Module 5, Objective 12, be able to describe the 5 steps in a neural reflex and be able to classify reflex types. Neural reflexes are rapid automatic responses to stimuli, basic building blocks of neural function. Specific reflexes produce the same motor response each time, and there's 5 basic components of a reflex arc. Here they are. We'll go over each of these in turn. So the 5 basic steps of a spinal reflex arc. 1, you're going to have a stimulus that activates a receptor. If you consider a pain receptor in the hand, any stimulus could activate that receptor, whether you stab that stimulus or that receptor rather with a pin, or you place your hand on a hot plate. They're all going to activate a receptor. And that receptor, with enough stimulation, is going to create an action potential that is then going to be carried by that sensory neuron to the spinal cord. It enters the spinal cord via the posterior root. Remember, the posterior root carries sensory information. Once in the spinal cord, information processing occurs. This usually involves one or more interneurons, and those interneurons will then stimulate action potentials in motor neurons. Those motor neuron axons are going to leave the spinal cord via the anterior root, and they're going to travel then to their effector. In the case of a motor neuron, their effector is going to be a muscle or gland. Here we actually see that in diagrammatic form. We have step 1, the arrival of a stimulus and the activation of receptors. So as an individual places their hand on a tack, the pain associated with that action is going to stimulate a sensory neuron. We see that here, and that receptor is going to carry an action potential to the spinal cord. Once in the spinal cord, that sensory neuron is going to synapse with an interneuron, and we see that here in white. And the interneuron will process that information. It often sends a collateral to the brain so that we can become consciously aware of what just happened. But in addition to that, it's going to synapse with a motor neuron, which will exit the spinal cord via the anterior root and synapse ultimately with an effector. And in this case, we're looking at the biceps brachii. It's going to cause the biceps brachii muscle to contract, and in doing so, we're going to flex at the elbow, removing our hand from the tack. Now, this process is very timely. It has to be for survival purposes. So you place your hand on a tack, the signal quickly goes to the spinal cord, quickly relayed to the effector, i.e. the skeletal muscle, and then that skeletal muscle contracts and you remove your hand from the danger. Again, this is handled at the level of the spinal cord. The brain may be notified milliseconds later, but it has no control over the reflex. We can classify reflexes into 4 different types. They can be classified developmentally by motor response complexity of the circuitry, as well as the site of processing that information. Here's a figure that sort of breaks that down. The next slides go into each of these categories individually, and we'll start with the development of reflexes. Reflexes can be innate or acquired. Innate means you're born with them. So withdrawal, chewing, suckling, visual tracking, these are all things that are inborn, things that are innate, things that one is born with. Acquired reflexes occur, we learn them through repetition. So these are rapid, automatic, learned motor patterns, and repetition enhances them. So for example, the textbook uses the braking of the car. We become, through repetition, very well trained reflexively to brake the car under certain circumstances, to hit the brake on the car. I've seen other sources cite skiing and certain sports where it almost becomes reflexive, one's actions. So these are acquired reflexes. We can also divide reflexes by their motor response. Somatic reflexes are reflexes that are controlled by skeletal muscles. Remember, somatic and skeletal muscle go hand in hand. These tend to be either superficial or deep. Superficial reflexes, these are reflexes in the skin or the mucous membranes, while deep reflexes are more muscular in terms of the knee-jerk reflex or the patellar reflex. Visceral reflexes control other effectors such as smooth and cardiac muscles or glands. So by the motor response, we can divide them into somatic or visceral. The complexity of the circuit, we have some reflexes that are monosomatic, that exhibit only one synapse. And of course, this is going to eliminate, or at least reduce, synaptic delay, that 0.2 to 0.5 millisecond delay associated with a synapse. So this will greatly enhance the speed in which that message is carried. Polysynaptic reflexes refer to having many synapses. Poly refers to many. These are slower. There's a delay due to the increased number of synapses that are present. Okay. And then lastly, the side of that information processing. Spinal reflex is processed in the spinal cord. Cranial reflexes processed in the brain.